Wow, 5 stars. Interesting one. Really? I lost half of hour on looking for products that even don't suit me. Is there really no such a system that can sort reviews based on their helpfulness?
Don't worry, our team have a solution.
I believe that most of you, at least once in your life, bought something online. And when you look at the product, you try to understand will it suit you or not. You're doing it by characteristics of the product and of course by its reviews. And if reviews are such as you've seen previously, like cool, good, bad, awesome and things like this, it will not help you to form your opinion on the product. And it's better to have such a system which will sort the reviews based on its helpfulness. So during our project we considered such a company which sells electronics and home appliance, both offline and online, and at their website they want to implement a system which will help them to sort the reviews based on some helpfulness. This company would have an objective to increase their rate, their prestige from the customer's point of view by introducing such a system. And as a data mining objectives, we would like to predict the helpfulness of the review with a deviation of 15%. First of all, we extracted our data. It was the data set on Amazon electronics reviews. We just simply extracted it from Kaggle by the Kaggle API. And here you can see the example of the features which are in this data set. It contains around 3 million of rows, and it's quite good because at least it contains not so much non values. Only 4 of them have some null values, and well, of course it contains like redundant features. The redundancy, for example, of the marketplace or product category. This is because product category is for all of the rows are electronics, and the marketplace is United States for all of the reviews. Here you can see that the reviews increased, number of reviews increased through time. So in recent time the people starts to make more reviews. It's more popular right now to write a review on the product, which is quite good, and it shows that such a system may be helpful. Actually, we mainly focused on some of the categories, like star rating of the review from 1 to 5, the integer number, the number of helpful votes. It means when the people write the review, someone can like or dislike the review, and the volume.
Moving towards the data understanding, we want to highlight several insights. First one is about star rating distribution. It is polynomial one, and the biggest amount has rating 50, meaning that almost often people do not get in deep and just send 5 stars, and that's all. Also, the next graph shows that the Vine program started at 2007, and its distribution is much enough, but the amount of these reviews is not so big. So we want to highlight another point, that our dataset doesn't have doesn't have the label, so we extract it ourselves. As a main point from social opinion, we thought that based on the Amazon description, We included wine and number helpful votes divided by the number of total votes as the most powerful as a label to our data set. Moving towards the data preprocessing, we firstly encode date with cyclical feature, and then we have two big important features, text features, that is body review and headline. With headline it's not so big, so we used embedding. For body description we add keywords from it and also sentiments of the review body. Also we add length of this text. After that we used ordinal encoding for IDs and then scale all the data, of course with sampling, because our data set is big and we took only the most recent and suitable ones, for meaning that, for example, total votes must be more than 10.
Moving from the data preparation to the data modeling, first of all we need to mention that as far as we want to predict helpfulness, which is a continuous value between 0 and 1, we consider it as a regression task. So we took 4 different models, the CatBoost, ElasticNet, Neural Network, and the Random Forest. We trained those models on the train test split of our dataset, and fine-tuned the parameters, optimized the models with help of halving grid search. Here you can see the results of the model's evaluation with help of mean absolute error and root mean square error, and also the prediction time of each model. As far as you can see, the CatBoost regressor showed the best result. And this model is good not only for the data analysts based on the metrics, but for business as well, because the model is interpretable and quite fast. As the future steps for our project, the first one is we can test the system on the real application. Maybe it can show some different results, and we can look on the system not from theoretical point of view, but from the point of view of real applications. The other one is the project deployment. Here we can stack a bit with the potential risk. The risk is based on the situation that our label was the custom one, and as far as we trained our models on the Amazon dataset, the results may be a bit different from the results which may be obtained from the users for our real website which we considered. However, as far as the business objectiveness was achieved fully, we can try to deploy the project. The other potential step is to conduct another iteration of CRISP methodology, and maybe we can obtain even better results by using another model or additional data set, which will help us.